Our next example problem asks us how many oxygen atoms are present in 53 grams of Na2CO3. So we are now we're going to have to go from grams to moles, then from moles to atoms. So we know that 1 mole of Na2CO3 is equal to 6.022 times 10 to the 23rd Na2CO3 molecules. And we can use the periodic table to determine how many grams are going to be present per mole. So if we look at the periodic table, sodium has a molar mass of 23, carbon 12, oxygen 16. So 23 times 2 plus 12 plus 3 times 16 is going to equal 106 grams. So 1 mole of Na2CO3 is equal to 106 grams. We are initially starting out with 53 grams of Na2CO3. So first we need to convert these grams over to moles. We know that 1 mole of Na2CO3 is equal to 106 grams. So we'll put the 106 grams of sodium carbonate down here in the denominator. Then in the numerator, we have 1 mole of Na2CO3. We also know that for every 1 mole of Na2CO3, there are 3 moles of oxygen, because there's 3 oxygens in this particular formula. For every 1 mole of oxygen, there are 6.022 times 10 to the 23rd oxygen atoms. So if we're trying to determine the number of oxygen atoms, we first need to go from grams of sodium carbonate to moles of sodium carbonate, then moles of sodium carbonate to moles of oxygen, and moles of oxygen to atoms of oxygen. When we go through and perform this calculation, we get 9.0 times 10 to the 23rd oxygen atoms. And we need to now check for our significant figures. We initially start with 2 significant figures. When we're making conversion factors with one in terms of grams and moles and how many moles you have in different coefficients here, those are exact numbers. So they're going to have an infinite amount of significant figures. So what's limiting us in this calculation is the 2 significant figures from the number 53 in terms of grams of the sodium carbonate. So our final answer has to have 2 significant figures, and we have it here listed correctly. So 53 grams of sodium carbonate are going to have 9.0 times 10 to the 23rd oxygen